How's everyone doing? Hi, Babycastles. Just gonna let people filter in, and I will share the repo up here. You can see it's imdb enhanced search. So one thing, if for those of us following along at home, will be to make sure that you have Python 3 installed. So, way you can check that would be to type Python and hit enter. And if it's installed, let's increase the size here, you'll see that it'll say Python 3 dash dot something something. Hey Joe, good to see you. Keep on writing, man. I'm going to read some more of that soon. Thanks for sending love. It's possible when you type Python that this might come up as a version 2, in which case you may need to try writing Python 3 . Or you might have to install it. And there's a link here in the repo to install Python for anybody who doesn't have it installed yet. Cool. So let's start to play around with this while we wait for people to trickle in. So the first thing you're going to want to do is get the repo downloaded. Awesome, thanks Jessica. So I want to check anybody out there not able to run Python and see that they have version 3. If you do, just feel free to ask any questions in the chat. Yep, the link's there. I'm going to turn off the music too. Hopefully we're sufficiently chilled out from it. Hi, film fan. How's it going? All right. Thanks for coming, everyone. So, this is finding custom films with Python. So the idea is that I went to IMDb to search for movies, and I found that some of the results were a little, if you're having any issues. Okay, awesome. Yeah, we got Film Fan. So if anybody has any questions with Python installation stuff, feel free to reach out to either Jessica or Film Fan. So IMDb provides an advanced search themselves, which allows you to filter by quite a few different data points. But one thing about building this on your own it allows you to do a lot more sort of custom applications with it, and that's sort of what we're going to be going over today. And as it turns out, IMDb, I was searching to see if they had like a database, and they actually provide all of their data, I found via Google, all subsets of their data for access to customers and for personal and non-commercial use. So, this is all freely available. So my usage here, I don't think you could necessarily sell a product legally if you were to use their data set, but for personal usage, as long as you're doing it for free and not trying to make any money off it, it's all here for you to download. And that is what I did, and so this workshop is sort of by using Python and this data set they have here, you can write your own film search. Something similar was one of the first things I read. Oh, nice. Yeah, it's a good use case, I think, you know. Would make anybody want to pick up programming, I think, you know. If you want to find cool movies, it's definitely a nice way to get into it, for sure. That's awesome. Yeah, so the idea was, by using Python, we can parse this data and start to write our own custom queries to get sort of interesting results. And as it turns out, you can also kind of like pop them open in your browser and do some things that are a little bit more customized and personal than if you were just to use what they have available in the web normally. Cool. So the first thing we're going to want to do is once you've gotten to, yes, it's true. And it's, you know, it's nice with Python too, because you don't have to write a whole lot of code, which is great too. So this is the URL again. And what we're going to do is, I'm going to walk you guys through how to get this running. So I think the structure of this will be, first we'll just get it running, and then we can actually explain how it all works once we have it working. So you can go ahead and click clone or download here, and so you can download a zip. You can also use Git, if you're familiar with that, to check out the repo via the command line, but we'll just go through the basic usage here, which would be to download zip. I'm going to be doing it on Windows. A lot of you probably on Mac, but I believe Mac has built-in unzipping capabilities. So once you've downloaded it, you're going to go to your download, and you're going to unzip it. There it is. Cool. And once you have that unzipped, you're going to use the cd command, which is change directory, to the path to the download. So in my case, that's in my downloads folder. And now I'm actually in the code repository here. So yeah, and you're going to want to use a command prompt to do this. So on Mac, you can use, that's the HTTP URL for cloning. Thanks, Jessica. If anybody has any trouble with this, just please feel free to reach out, shout out. So you're going to want to open either on Windows, you can use command by typing cmd, or PowerShell, which is what I use. And if you're on Mac, I think you'll type terminal in your Finder, and that will bring up the equivalent for Mac. Cool. So then I'm going to cd, like I said, into the path, and that will bring me into it. And from here, we can install requirements. Now, first, we're going to want to make sure that we have Python installed. So the idea is that you're going to want to be able to type Python, and what's going to come up is it's going to say Python and start with the number 3 dot something dot something. And as long as that comes up, you're going to be good to go. So you can also, after you check that, you can type exit, open parentheses, close parentheses, and hit enter, and that'll get you out of Python. Now, it's possible it'll say, your terminal will say something to the equivalent of that it's not installed, or that you have the wrong version if you have 2. And in that case, it's possible you have Python 3 installed. You can check by typing Python 3. If that doesn't work, you're probably going to need to install Python. And to do that, you're going to just, you can just follow this download link here. And Homebrew is actually a really good way to do it if you're on Mac, if you don't have Python yet. And yeah, we're gonna install requirements. And so if you have Python 3, I think it should come pre-installed with pip, so there should be no need to install that. And you can just install all the requirements via this pip command here. The pip install, you can just specify a package name, and then if you use -r, that allows you to target a text file which has a list of requirements. In our case, you can also bind them to a particular version. We're not doing that just because I didn't bother. But we're using the Python web request library. Yeah, and it may be pip3. There's a few different commands that we can use to troubleshoot if people aren't getting it. I've also even seen, like, Python 3-m pip install. If anybody has any issues accessing pip, reach out to any of Jessica or myself or FilmBand, and we can show you a different command that may work. But yeah, so this requirements file has all of the exterior all the custom libraries that we're using that aren't built into Python that are required to run the code today. So we're using the Python request library and pandas. Request is for web requests, and pandas is for basically traversing data sets, in our case, in CSV format. Cool. So yeah, like Jessica was showing before, you can install all the requirements by using this pip command here. I already have them all installed, but I'm going to run it anyway. And so it basically just said requirement already satisfied for all of these, but if you don't have it yet, it'll just install all this for you. And from there, you're good to go. So to run a Python script, you're just going to type Python or Python 3 or whatever alias you have to Python, and then we're going to run runner.py. We have 3 different Python files in here. Runner.py is the actual running file. Let's go ahead and do that. Cool. And so you'll see it's going to start downloading data from imdb. There's a couple different files it's going to download. And note that they're in TSV format, which is tab separated. Instead of com separated, you may have seen CSV before. Ah, thanks. And it's in gzip format. Yeah, the left panel is kind of tiny, and I didn't figure out how to change the size of it, because I'm able to change the size of my text here. One thing I can do, we can just look at the video is blocking a bit of the upper left code. Oh, okay. Yeah, let me, I don't actually need to be in here anyway. Plus I'm like apparently shrouded in darkness anyway. Maybe I'll go up here. So I can zoom this in too. These are our files. Okay, cool. Glad that worked. So apparently, one moment. There we go. I think I changed the settings on my video anyway. Yeah, big font. Cool. So let's go back to what this was doing. So this downloads data from the imdb website, a couple different files. No problem. This title basics file and this title ratings. They're in tab separated format, and they're gzipped, which is just a zip format. I believe, it seems when I was doing this that it actually just tends to take care of the gzip all for you. You don't have to explicitly unzip anything, which is really nice. So it'll tell you that it's downloading from basics, the basics file, and then it's telling you it's downloading the ratings file, and then it has to read them into memory. It'll give you this little warning, which I haven't read too much into because it seems like you can safely ignore it for now. And then it actually deletes the tab separated volume once it's done and in memory because we don't really need it anymore. And then it reads the ratings. So basically the thing to understand here is IMDb provides a few different data sets here, and it tells you what they all contain. They're basically, just think of them as spreadsheets. And the title one has the title and the actual ID of the film, their special unique ID. And what we're after is, we're also after the ratings. And so they come in separate files, but they can be combined and merged by having a common tconst unique ID. So this ID is what links these two volumes of data together. And so, yeah, you'll see that they end up getting merged. So they get downloaded, read into memory, then deleted the initial file, and then they get merged together. And we do that using pandas. And I need to make my terminal a little bigger here. Okay. Once it merges, it sanitizes the data. I just found that some of the data as it was a little sloppy in some parts, so I cleaned some stuff up. You can ignore these type errors. That's just some debug info. And then it tells you how many records we downloaded. So it looks like we downloaded 1,138,000 films once we merged the records together. and then that memory, that data in memory actually gets written to a file, and then from that file, we then build those films into memory again. So the idea here is that the first time we run this, it's going to download the data and write a file after cleaning everything up and merging it. And then on subsequent times we run it, if that file is present, it won't download it again. So basically, it feels a little weird. It's like starting from files, putting them into memory, writing a new file, and then putting it back into memory. But the point is, on the first run, to download everything and then put it into memory. So then we apply our filters once we build it into memory. So you'll see that my filters here are rated at least 7.5 stars, with at least 300 reviews existing, but no more than 35,000. Made on or after 1966. I prefer more modern films like after that year, but you know, it's sort of an arbitrary criterion. And with the genre of fantasy, with the genre of horror, no TV, because IMDb includes TV results, which I'm not interested in, and no video games. IMDb also has video game results, which I'm also not interested in. So this was a relatively strict filter set, and we got 19 results here. So once that's done, you can just hit enter, and whatever web browser you have open, it will open the movie in your browser. So it picked Gorillaz Clint Eastwood. Apparently that's a fantasy horror film, according to IMDb, and it will just actually pop it open in my browser. And then it's going to delete that from the list, and we'll pick another random one. We hit enter, and it opens up, looks like a lot of music videos, The Killers, Here With Me. And you'll see that it says both the title and the URL and how many results are remaining after we open it. So the Hourglass Sanatorium, this actually looks kind of cool. I've never heard of this. This might be something where I'd be like, okay, I'll put that on my Letterboxd watch list, or I might check out YouTube and see like, what is this all about? This actually looks pretty cool. Must have been remastered or something. It's from '73. It looks pretty nice. But yeah, that's the basic gist of nice. What'd you get? Let's see. The Sorcerer's Apprentice. Cool. Oh, I've not heard of that one either. It's Czechoslovakian. Very cool. Yeah, so that's that is basically what we've built here, and we might now. I'm gonna press Control on Windows. I'm gonna press Control C twice to quit out of it. I think it's Apple C twice to quit out on Mac. But what we can do now is we can try different filters. Now that we have it running, we can experiment with doing different things. And so in your folder of this download, you're going to find a file called config.ini. So the idea behind this file is that if you don't feel like getting too heavy on the code, you can actually control your search by editing this configuration file without having to write any code, which is kind of nice. So I'm going to open it up with Notepad++, or you can use PyCharm or whatever file you want. So this is just a configuration file, which Python has some built-in libraries that can parse these sort of files, and it should be fairly readable. Below filters here, there's the system data and these IMDb columns and these filter strings, and you don't have to worry about too much of this yet other than the filters right here. So you'll see the first one, TV results equals no. Like I said before, IMDb includes television results, so you can include or disclude them by either writing yes or no here. Video game results, also no. Genre filter, this is yes. So if you want to filter by genre, you'll just change this either to yes or no, depending on your use case. Now, the thing to note about this is that this genre filter is connected here to this genres filter. That's what I have, fantasy and horror here. I use code. Yeah, you can actually, in your command line, you can, I think I could do that too. I think you can type code config dot, or I might do Notepad++. I think you can even do it from, like Jessica was saying, from the command line. Hit enter, and then it'll open right up in your text editor, whichever one you want. So we have fantasy and horror here, but I've actually been using documentary a lot. So if you have two genres you want to use, you just separate them by commas. And if you have one, you just simply type the one you want. And the values, yep, you could use Atom, Vim, if that's your style. These genres that I have here, this is a code comment in the config file. These are all valid genres. I looked through IMDb at all the, I looked at all the results I downloaded, and I found just the unique names, and these are all genres that you might find. And I think it is case sensitive, just so make sure you capitalize the first letter. I forgot if I made that case insensitive, but so let's try changing this to documentary. So now we're still going to be filtering on genre, documentaries. We could change this to, I don't know, 1960, maybe for documentaries. We don't mind old stuff as much. Minimum rating, maybe, it doesn't have to be super well reviewed, 6.2 maybe is good. And the minimum number of votes and the maximum number of votes I find is like a really powerful filter, because a lot of the times when you search just the basic 3 genres still separated by commas, 3+, as 2 or more will be separated with commas, and that it should be valid to use as many as you want. I've only experimented with 1, 2, or 0, but you should be able to continue to separate by commas and add to the list. Cool. So, minimum rating 6.2, and now the maximum and minimum number of votes I find is a pretty powerful filter. This is actually what really got me interested in this in the first place, is when I was using their basic search, I was finding sort of obvious results and stuff that wasn't very interesting to me. So I decided to build a minimum maximum vote filter to sort of find a sweet spot between films that aren't too obscure but aren't too popular. And my way of measuring that was, I thought, like, okay, what's a really popular cult film that I'd want to still be able to see? So I thought Repo Man was like a good baseline. Like, I'd like to be able to find movies like Repo Man, but nothing more popular than Repo Man. And I found it had 32,000 votes, so I rounded up to 35 because I like numbers like that are easier to work with. And I decided that's my upper limit. But maybe with documentaries, more popular is okay. We could do 40,000, right? And so now that we've changed all our filters, we can go back to the terminal, and we can press up a few times, and it should say Python and our statement here, so we can go ahead and run this again. So now you notice it won't have to download this time because the data set already exists. So it's just going to build the films into memory, filter them, which are rated at least 6.2 with at least 300 reviews, but no more than 40,000, made on or after 1960, with the genre of documentary, no TV, no video games, although TV would actually be pretty cool for documentaries, but that's okay for now. And we got 3,500 results with these criteria. So we can go ahead and hit enter, and we have this instant dreams. It tells the story of a group of scientists, I think that's supposed to be plural, who are trying to unravel the chemical formula of Polaroid and Polaroid users that eagerly, oh wait, it's rebirth. Huh. I'm not sure that would be what I was looking for, but that sounds at least not too obvious. That's kind of cool. Is the man who is tall happy? An animated conversation with Noam Chomsky. Yeah, definitely hadn't heard of this one. Nice thing about IMDb is they do have some built-in videos here, which is kind of cool.
In the ground.
You gotta turn Chomsky up, he's very quiet.
Exactly identical to the original tree. Is that new one the same willow tree? Why not? It's not so simple.
As you can see, I felt a bit stupid here.
Why? Visual experience is just... But then the question is, well, what are those concepts?
I mean, hour and 28 minutes. I'd give it a shot. We're in quarantine, I'd watch most things that are at least slightly interesting looking at this point. Cool. Alright, yeah, so that is basically how you use this film finder. I think I wanted to see if anybody has any, yeah, right, an unknown one. If anybody has any questions on running, I think the idea for me at this point was to go through the actual running of it, and now we can maybe dive into some of the code and how we built this. But I wanted to give people a chance to kind of understand this configuration file, make sure they can run it, and see what they think. Oh, and maybe one other important thing to note without diving into the code is that there is one filter in the system that you might be interested in called rebuild. Now, the idea behind rebuild is the way this, the logic of this runner is built. If you've never run it before, aka you don't have the IMDb data already downloaded, it will detect that and automatically download the data. On subsequent runs, it won't do it again because it exists. However, there is this rebuild flag, and if you set this to yes, the system will know to rebuild your data set, because I think IMDb updates this data set with some regularity, I assume. If you downloaded this a while ago and some time has passed, you may want to get the latest set, depending on if they've added anything. So I changed that to yes. I saved the file, and I'm going to go ahead and run this again. And it's actually not doing what I expected. Did I actually change this to yes? It's possible I broke that, but the intent behind that one anyway is to say if the system data rebuild equals yes, to go ahead and rebuild the data. So I'll get that updated case. It's supposed to be case insensitive, and this is a lowercase yes. So, interestingly, oh, maybe looks like it's wrong here. Oh, you know what? I know what it is. I have two different, I re-downloaded this, this repository. This is the right file. I was just working off of my other repo. So yeah, when I hit rebuild equals yes, you'll see that it says downloading data again. And so you have the ability to toggle this because obviously it's slower and uses your internet to have to retrieve it from IMDb. So you might not want to do that every time either. You don't feel like waiting, or you don't want to like waste, energy for the sake of the planet, or you just I don't have an internet connection or whatever else. But it's fairly quick to download. It's not a giant file, but in my opinion, there's no need to do it more than a few times a month, I would say. But yeah, and then it goes ahead and does all the sanitizing and filtering, and you can continue to pop this as needed. Cool. All right, yeah, so if people are comfortable with that and that makes sense, I'm going to go ahead and move on to actually breaking down some of the code and how we can write something like this ourselves. Now that we've gone through the configuration file, which I'm actually going to back up to my other directory. Cool. All right, so the first file to really understand here is our runner file. I'm going to just change my windows up here. This is the heart of, well, it's not the heart of it, I guess, but this would be the actual entry point into our code here. And it's not, this is not an object-oriented file, while the other files are. This basically just imports the necessary things and runs the actual classes that we've built. And so there's a few important files to understand. There's the configuration file, which we already went over, and then the important ones are runner, which runs everything, and then build and filter. And these names were intended to capture the purpose behind each of them. Build actually builds the data that includes downloading it from IMDb and actually like building it all together, merging the spreadsheets, doing a few other things. And filtering is the actual piece that does the searching through it based on your criteria. So let's take a look at runner. Cool. Right, so we use a few libraries here, and I guess libraries are just more or less somebody else's code. I'm not going to get too technical with my explanation, but in Python uses the term libraries, which is basically just code within the language to do certain operations. And one important thing to understand is the difference between sort of a third-party library or a built-in library. All of the third-party libraries we're using here are enumerated out in the requirements.txt file. So requests is a very popular web requesting library, and pandas is a very popular data parsing library. A lot of data scientists use pandas, I think. And otherwise, Python has a lot of really good built-in libraries as well. So build and filter are my classes here, or libraries. The first one we end up using is config parser, and that allows us to parse this config.ini file. And we also use the OS library, specifically path, which allows us to work with different sort of like file system operations. So here, the first thing we do is we set up our config file. The name is config.ini, and then we create a new config parser, and then we read the config file. And then from that config file that we read, we set up some values. We set up our system data, which you basically treat this as a dictionary, and you can use the key based on the headings that you put here. So these are just the headings, which end up being the keys of the dictionary, and you can access them by just writing their name in quotes. And then within each of those headers, there are filters within that. So again, they're dictionary keys. So you'll see that I get the system data. From the system data, I get the data file name. So you'll see that like right here, imdb data.csv. We set up some values like that. We get our encoding format. We get our imdb ID, which is what they call tconst. And the first thing is, like I was saying, on our first run, when the user requests a data rebuild, when the configuration says yes, or it's on the first run. So basically, if not path is file data file name, that's saying if the file doesn't exist, aka this is the first run, or we've explicitly requested a rebuild, we're going to go ahead and build the data. So build, this is the constructor here. Now let's go over to the build file. So the build class, when you initiate it, takes an encoding style, a column to merge on, a URL, an input separator, and a null character. And then in our init method, that's just the function that gets run when you instantiate an object. It goes ahead and assigns the values based on what you instantiated it with. And that is what we're doing here in the runner. We're setting up some file name variables here. Check my chat, see if hopefully everybody's following along. Feel free to jump in and ask questions if you're not. So the first important operation here we do after we've instantiated our build object is we go ahead and actually download the data that we need. We have a function here in our build class called download imdb data. It takes a file name, self, and name. So what it does is it formulates a full path by combining the imdb URL that we passed in when creating the object and the name of the file. And it says downloading data from the path, and we use the request library that's up here to make a web request. And so we can talk about the request library a little bit here. So the request library is basically just a popular HTTP library. You can do all sorts of things over the web without needing a web browser, and one of them is making web requests using a programming language like Python. And now Python does have some built-in ways to do web requests. I think it's the HTTP lib is the built-in way of doing it, but I haven't used it a lot myself personally, and I would say like 90% of pulling that number out of thin air, but I would say like 90% of Python users probably are just fine using request. It's really popular and simplifies a lot of complicated stuff that many people don't really care about. Some people do, and request you can also configure quite a bit too, but look how easy this is right here. I can just say request.get full path, and that's just going to download data from a URL for me, which is pretty nice. Just looking at my notes here. Cool. From some sample code, yeah. Yeah, I mean, I know request probably uses the HTTP library. Much of the sample code you write, yeah. No, and it's nice because, I mean, if you're doing that, you at least don't have to tell anybody to run a prerequisite step. There's definitely a lot of power in being able to do things as natively as possible. But, you know, there's all sorts of options. That's one of the nice things about Python, too, with libraries is there's quite a few powerful options. Oh, you meant requests. Yeah, fair enough. Cool. Cool. So, where are we? Yeah, so we go ahead and download that with our third-party request library. And then we write the results of that download, because this download is currently sitting in memory, and we write it to a file using OS open, which actually opens the file and then writes it to the file system. And this is write bytes. I found that was necessary to avoid some encoding issues. So we download both of those file sets, both the basics file name and the ratings file, and then we read them into memory. And I believe read data, yeah, we should take a look at what that does. So once you've downloaded it, we read it into memory. We do a little step here to encode and decode our separation character. So you'll see in the configuration file, where is it, that we're actually separating, this is a tab separated volume, and so I'm indicating that in the configuration file and putting the value here. And then we're reading the CSV using pandas with the separator. And we say the encoding is the encoding that we passed in, which is UTF-8 in our configuration file. And then we actually delete the initial file, because now that it's in memory, we don't really need that tab separated file anymore. We read it and then we return the result. So you'll see here in the runner, we get our basics and ratings read into memory, and we delete the initial files. Then we merge them. So this is the important reason that we use pandas. It sort of lets you treat like a spreadsheet or a CSV file almost like a database. So this merge right here, we use pandas.merge. Data left and data right, we have the parameter names. They're sort of arbitrary names. In our case, we're merging basics and ratings. And then we're merging them on the self.merge column, which we build in our configuration. And the merge column, let's see here. Merge column, when we build the runner, our merge column is the imdb ID. And if we look at imdb ID in our configuration file, that is tconst. So that's just the value that they use at IMDb to signify a unique ID. So once we merge them together using pandas, then we have this merged in-memory object. Now what we do from here is I run the sanitization method. I wanted to convert all of their blank entries into Python none keyword. That way Python would know that it's a null, and I go ahead and basically replace all of the blanks. I think they specify blanks. I think they show up as like a new line character here, and so I escape that here, put it in there, and then this is just going to replace all of them with nuns. I found on some of the columns it didn't work, so I just swallow that error I haven't had a problem with it. So you see I'll try to replace the value, and then I accept any type errors, and I just let the user know that it happened, and to basically ignore it. It's not a big deal. So once we have those merged and sanitized, we're going to actually write that data back to a CSV. So we're basically downloading two, sort of separate data sets, and then we're merging them, deleting the initial ones, and then putting it back down into one file. So then you have your good data set, and it's always available after that, and you don't have to re-download it unless you choose to actually rebuild. So we'll merge that. That's the sort of flow of the builder. Also important is the filtering. So the filter is also like, it's pretty similar to the builder. The filter is similar to the builder in the sense that they're both, classes, and it's object-oriented programming. So in our filter class here, we have another init method, which sets up a few values, and then we also do, we parse our configuration file, so we use config parser again. We read the configuration file, and we set up some filters based on that are specified in our configuration file. We parse the config, and then we actually load the CSV data we have into memory and set it to our data field. Load data just uses, I'm not using pandas anymore. I didn't really find it was necessary. After this, you can use pandas to do a lot of what I'm doing here, but I tried to use it as lightly as possible. So we use a CSV dictator, and we open the data file name, and we set our encoding. And then once we have that loaded, we can actually run our filters based on whatever's in the configuration file. So I'll show you how that works. This is the bulk of our code, line 93 to 29. There's like 60 lines of code here to do the filtering. This might be a little lighter if you used pandas, but what I used was this thing called list comprehensions, which are a pretty nice feature of, I believe, Python 3. I don't know if it was available in Python 2, or at least I think syntactically it may have changed. Jessica might know more about that than I do. And I thought I even have a link that I can share. Nice. So this is a pretty powerful piece of Python, and I found that I was just fine using this rather than pandas itself, because you can just load the data into memory. Oh, nice. Yeah, if you want to share that, that'd be awesome. List comprehensions are cool, and they're sort of, I think, very Pythonic way of filtering data. Pythonic being kind of like the, Python has a sort of concept of Pythonic, which is sort of just writing code the way they want you to. In a way that's inherent, sort of a hallmark of the style of the language, if you will. So running filters, that's what we do first here. We build an empty array called filtered, and we first go through our rating. So we get our values off of our config file for average rating, minimum rating, and then we say rated at least and print it out. That way you know exactly how it's filtering. So first we want to check that the average column exists before checking the column. So MV for MV, that means movie, in self.data, if the average column exists in the movie and the float value of the average column is greater than or equal to our minimum rating. So basically saying, is it at least rated the value that I specified? And then we set our data to the filtered result here. Note that colon, that I'm actually not exactly sure what that operator is doing there, but it is important. So once you filter down the rating, the next thing we go through is popularity. So we have our number of votes, our minimum number of votes, and our maximum number of votes. So with at least X reviews, but no more than Y, is what it ends up printing out. And we filter MV for MV, again that's movie, in the data if the integer value, so it's not a float, reviews, the number of reviews, you can't have a half review, you can only have whole numbers, so we're using int if the number of votes is greater than or equal to the minimum number of votes, and the number of votes is greater or less than or equal to the maximum number of votes. So that's going to be the filter there. Then we go down to modernity, what I'm calling basically the start year. Now here's where if you wanted to say a maximum year, maybe you have a minimum year, but you also have a maximum year, you don't want movies to be too modern, you could modify the code here and add another configuration value, and you could do sort of similar to the reviews where you could do greater than or equal to X or less than or equal to Y. But in our case, we're just using a minimum year. But just to note, this would be a good place to change the code if you wanted to do something on your own. Oops, let's do that. So made on or after this year, movie for movie and self-data if there is MV for MV. Yeah, that's basically just saying for every, this is almost like a for loop if you've ever seen a for loop, these list comprehensions. So, okay, cool, the colon is the slice. Yeah, so the list I sent up there, or the link I sent up there on list comprehensions will have a better explanation, but MV for MV is almost treating this like a for loop, and it's saying basically movie, I'm aliasing every entry in self.data as MV, just to say movie. MV for MV is saying for every movie in this data set, if, and then basically there's these conditionals. So let's take a look at the documentation together. I think that might be helpful. So a list comprehension consists of brackets containing expression followed by a for clause, then 0 or more for or if clauses. Yeah, exactly. Right. If there are 1,000 movies, repeat 1,000 times. So it's basically that for clause. That is what the MV for MV is, I believe. So it's a for clause followed by if clause. So for every value in self.data, which is all our movies, which is why I call it MV, it's just a way of saying movie. Yeah, no problem. Yeah, it's a little confusing for sure. But yeah, so this is just an alias for each value in it. And I think you don't have to do every value in this initial for clause, but I'm saying for every movie in the data, if there is not a start year column, basically if there's no year listed, I still want to look at it, or if the integer value of the start year column is greater than or equal to the minimum year I specified. It saves you from having to find the length separately and then pass it to the for loop as a variable. Yeah, saves you a few lines. Right, that's right. Yeah, so that's what MV for MV is. That's the for clause part of the list comprehension. Then the for or if clauses, these are everything after MV for MV and self-data. These are my if clauses, right? If. So I think you probably could, I haven't done, honestly, a for loop in Python in a while. Let's see here. You could, though, say something like for MV in self.data, if MV if not MV or this, return, no, we could do something like this. We could say my results equals a blank array, and then we could say my results dot append MV. And then we could say self.data equals my results, right? This would be the old school, not old school, but like this would be the sort of for loop way of doing what I'm doing here on line 58. It would be saying for MV in self.data, if not MV start your column, or in my results dot append this movie, and then by the end of it, my results would have all of the data. Plus includes the or, so a lot happening in that line. Yeah, right. Yeah, there is a lot happening. So I don't know. I mean, either style is honestly totally valid, but you know, this is a little fancier, I guess. It's like kind of cleaner, but it's not necessarily easier to read. So, you know, it's up to you. Oh, thanks. Yeah, no problem. This would be the sort of more explicit way of doing things. I'm gonna go ahead and undo that. So you have options. You can use a for loop. Yeah, that's fair. I think that's a good point. Cool. Right, so then, yeah, finally we go through here on our genre filter. So if the, I dot lower is to lowercase, its strip is to remove out white space. So if the genre filter is yes, if we are filtering genres, I'm going to, for each genre separated by commas, so we're going to go through every genre, that's why you can separate them with a comma, with a genre of X, and then we do MV for MV and self data if G, that's genre, stripped out of its white space, is in the movie column, then add that. This just says TV exclusion, so if TV results are no, we say if the TV string is not in the data. Video games, same thing. And then the only other thing we have in this one is this picking method, right? So that's how we build it. So we're going through the runner here, we run the filters, and now this is the core of the little loop here. Let's go ahead and run it. Let me know if anybody has any questions. I kind of just moved along there quickly, but I'm going to download the data again. I think I have to turn off my rerun next time. So we download our data, we write it, read it, merge it, sanitize, write the file, filter the file. And now you see here I have this little like looping mechanism. I can press enter, it'll pop a movie, the Bret Hart story, hell yeah. And you can just keep doing this, it's going to keep filtering down. So what's happening here is we're actually in an infinite loop, which can be a bad thing unless you want it to happen, in which case it can be a good thing. Infinite loops are good if you can control them. So with great power comes great responsibility. I've heard that one before. So what we do here is we run the actual app here, and we pick a film for the user on each request they make. So while true is just what's called a while loop. So while a condition is happening, let's continue to go in a loop here. So while true means basically forever until we quit the application. Input is a way to take user input that's built into Python. It's a built-in function. This is press enter for a movie, and then the text is whatever the user pressed in, and then if they pressed enter, we pick a movie. Otherwise, if they type something else, we don't do anything. So every time you press enter, it's going to run this filter pick method. And this is going to take self.data, which we've run the filters. So self.data has been narrowed down to our particular criteria, and it'll now be, we've searched through it. So random movie, we're going to use the random library here that's built into Python, and random choice, if you provide it an array, it will it'll pick a random value out of that array and return it. So I say random movie equals random choice self.data, and then I actually remove it from the list because we don't want to look at that movie again. Self.data remove that random movie. Then we get the ID from the movie by using the ID column, and then we get the title. And then we make a URL, which is the browser URL. That's just IMDb's, because they have two different URLs. They have one for the data set and one for the actual film. So I put that in here. And let's go back to our filter. We get the ID, we build the URL, and then we say opening this movie. And we use the Python built-in web browser library to actually open our web browser to the movie that we want to look at. And that's how it actually just launches each time like that. So we build the URL, we print out what we're going to do, and then we also say how many results are left. So if you've got, like, in our case 1590, it's probably not so interesting. But if you've only got a few results, because you had a very narrow set of criteria, you might be interested to know how many results you have left, because eventually you'll run out, and then it will say no films found or nothing left, because you're either in one of those two scenarios. And yeah, that's basically the core loop here of the app. And one of the things that is nice about doing this with code is that we can extend this in quite a few different ways. So I mean, before we dive into that though, are there any questions about how this is all written, or is this pretty clear to people? Hopefully that was at a good level and people were able to digest what we're talking about and run it at home. Cool. Awesome. Thanks. I'm glad. Yeah, so from here, it's really up to you what you'd want to do with it. The attempt for explaining this was not just to show you how you could also download data yourself, and actually though that was part of it, but there's also ways you could extend this. But before we talk about that, I actually had a friend show me. I mean, there's all kinds of data out there, and one of the things that I thought was interesting, the reason I did this, I'd been always wanting to do this, but I didn't know the data set was just available like that, and I thought to myself, well, what I could do would be to write what's called a scraper, and I could go to IMDb and I could, as a robot, search through every one of their records and download it myself. Now, they don't want you to do that. Some websites are friendly about that, and they have, most websites, or big websites, if you go to their main domain /robots.txt, they will tell you what you're allowed to do as a robot, or basically a Python script in our case. And IMDb doesn't let you do anything, I don't think. They disallow all of this. Now, there are ways to get around this. I'm not going to get into it, nor do I necessarily recommend you do that, but you can get around bot detection with some effort. But I thought I didn't want to do that because it's really hard to write a scraper. There's a lot to it, and I kind of shelved the concept until one day I thought, well, maybe I think I saw a tweet where someone was like, you really should check the API first before you write a scraper. And I think there was some argument about it, and but it turned out that it got me thinking, like, hey, maybe there are data sets for some of the stuff I'd like to use. And turns out, and so I searched IMDb MySQL database. There's a lot of insert verse web design making a scraper. Yeah, to put it frankly, it's a pain in the ass. So I searched IMDb database, and this is what came up. Their data sets. Yeah, it's a pain. There's a lot to it. So I found though that they had it available, and actually, I think my friend showed me a good GitHub of data sets. Awesome public data sets. Yeah, this is cool. Let me send this link here. So, you could, not only could you extend what I've done, but if you want to do something for a different type of data, these are really nice public data sets. IMDb is actually on here. Oops. Which is cool. And let's search here. IMDb and all kinds of other stuff if you're into these things. Yeah, please share. We're definitely interested. So yeah, you could download this data and you could do a similar thing, right? That's one thing you can do with it. Another thing you can do is right, we're picking these films out of a list here, and one thing that is a pretty fun use case would be like creating a Twitter bot. Because I know Twitter allows you to use their API, and a lot of people, I've seen one of my favorite applications, I've seen a lot of people take lines of dialogue from a film or a video game, probably like randomly picking it from a list, and then they tweet it once a day, so you get to kind of like continuously experience like little snippets of dialogue or conversation or something from a favorite film or game, and see it like every day in your Twitter feed. Oh, okay, cool. There's a Twitter tweetpy, looks like, or Twitter Python. Yeah, so there's actually some libraries for it. Let me see there. Right, because it would be cool to maybe tweet out obscure movies every day. Yeah, let's see which I'll check out. Cool, an easy to use Python library for accessing the Twitter API. Yeah, because this is probably going to make things pretty straightforward, I assume, rather than necessarily having to make web, because you could use the Python request library and make, Twitter doesn't make that, FYI. Okay, does Twitter make Twitter Python? No, okay. Neither one of them are officially official libraries, but so you could use the Python. A little more official would be to use the Python request library, like Jessica was just saying, and make web requests against the API. Alternatively, you could use one of these libraries, and you could put like, I could say tweepy right here in my requirements file, and then I could say, pip install. All of our SDKs are community made and encouraged. Nice. Requirements.txt. Nice, that's awesome. Yeah, so I just installed Tweepy by adding it to my requirements file and downloading it. And yeah, and then you could start to, take the results. You could make like a, and can help you if needed. Cool, yeah, I might be interested in that actually. Yeah, and so you could take the results that we have in filter, and maybe you could make a different class. That's what I would do. Like maybe call it twitter.py, and it could take in that set of data, or rather that one film result, and then I assume you'd have to probably do a few things. You'd first want to authenticate to your account. That's one of the first things they have here. We're not going to get into that because that would probably be the most complicated part of your journey in doing that authentication. Is naturally has a little bit to it. But then let's see some of these code snippets. Follow all. It looks like you can do following. I'm sure you can actually just tweet to code snippets, introduction, redirect user, API. Tweet. Let's see, you actually send a tweet. Google is often as easy to search documentation as even looking at docs. So yeah, I don't know, this one looks like it might be decent. Update status, hello Tweepy. Oh, update status. That looks pretty easy, right? So you can imagine, yeah, Googling is great, right? If docs are really well written, it can be pretty easy. Oh, this guide, yeah. So you can just say API.update status, and so you can imagine passing, this just takes a string, you could pass in the IMDb URL. I think IMDb even probably, that you could figure out what the image URL is for it, because I think one big thing that people will be taking like an actual still of the film, putting that into the tweet itself along with the URL. So I'll just send this in here too. And yeah, I don't know, if there's no other questions, I think that was really the heart of what I wanted to go over, show some extensions, and Jessica, if you want to add anything else, or anybody wants to talk to any of us afterward, feel free to message us. Time permitting, and assuming there's, could you show how you'd script an LF that distinguishes your combined no more results none found into distinct scenarios? Oh, thanks, Jessica. Yeah, no, I can do that. So distinguishes your combined no more results left / none found into distinct scenarios. So let's see, on pick, this line 109 here says no films found / left. Oh, thanks. Yeah, no, that was fun to do. I appreciate everybody showing up, and yeah, definitely. Let me just send my. You can reach out to me directly on Twitter. Is good. You can use that handle on Twitter and reach out to me there or follow me. Okay, so line 109 is the no more results found. So I can explain here. So what we do is we try to choose from the data. If there's nothing left, random.choice will throw an index error. So I'm anticipating that and just printing out no films found / left. but I'm curious, Dan, what you're wondering here. So this is, I think, what you're referring to. This is the block where you fall in, where if there's no movies left. And you were asking about distinct scenarios. I'm gonna put on some music too. Ah, interesting. I see. Right. Yeah, because this is this is the same thing for two different scenarios. I see what you're saying. One moment. All right. So I guess that would come down to distinguishing between it being the first time you're picking it or not, I think. Because pick is sort of agnostic to where you are. Maybe we wouldn't build it in pick then, right? So maybe if we wanted to be cheap about it, we could just do it right in the runner. That's actually not bad, right? Because we can say something. We could do it right here in the runner. So then it wouldn't be part of filter anymore. Here's what we could do. So we could treat filter, we could say pick is only going to happen on the first time, or rather if there was already results. So what we'll do is we'll say no films left. If we didn't, now we're going to assume that's going to be always the case here. And we can say we'll make a barrier from that happening here on line 54 in the runner itself. This isn't the best way to do it, but it's just, I think this would be the most straightforward for our purposes right here. So we could say if true, we could say print no films found, and we could just prompt the user. This way we don't have to hard quit. We could say no films found, standing by. Right, it's just hanging out at this point, and actually, let's scrap this for now. We could just exit it. I guess that you won't be able to see, if we exit immediately, it's gonna you won't be able to see the thing write it out. But we could just say let's just do nothing for now. I mean, we'll see what happens, right? But no films found. So right now we're saying if true. Now the filters, I don't believe there's a way to there's no built-in way. You could inspect the data property because it's not like it's private, and there's no, even encapsulation in Python isn't actually enforced. So I should be able to access directly self.data here. So I think we could say something like if filter.data, if the length of filter.data equals 0, we could say no films found. There's other ways of doing that. I think we could even just say if filter.data, if it's true, like, and if data has values, that would end up evaluating to true there. Let me just check. So Python, I know the length thing works. Check if array is empty. If not A, so yeah, if you could just say if filter.data, if not filter.data, print no films found, and Python, and then we can just say while true, pass. So that'll just keep our application running, but it won't allow us to drop into the other block. And we can test this by, let's set up some really strict criteria. Minimum number of votes is 5, maximum number is 6. So basically, only things with 5 or 6 votes in this category. That'll probably, hopefully, be nothing. Let's give it a shot here. Oh, that's actually a ton. Alright, let's not do that then. So let's say with 666 votes on either side, and it's gotta be a game show. Hopefully that's weird enough. No films found. Got 0 results. And now you can't do anything, but you can keyboard interrupt to get out. Versus if we go back, let's say like 700, and we'll do sport. Hopefully we get like 5 here. Let's see if we can do this. Got 1 result. Perfect. So I hit enter, and it goes opening a sunny day in hell. That doesn't sound that interesting to me. And then 0 results left. Press enter for a movie. No films left. So that's distinct from we never found any in the first place. And yeah, that's how we would build both use cases there. Cool. Hopefully that was clear. And again, I would actually probably do it in my filter class if I wasn't just doing this in front of everybody right now. But this is just one cheap way of doing it. You could make a new function, basically filter.checkData, and you could do that before you drop it in this wild tree block. Yeah, no problem. Yeah, any other questions? It was fun doing this. I hope everybody had a good time. Enshrouded in darkness again. Cool. All right, well again, yeah, my handle is Vampire Computer People, and the GitHub, again, is somewhere. Of course, no problem. I'm glad everybody enjoyed it. Thanks for coming out. Oh, thanks everyone. I really had a good time doing it. All right, take care. I'm gonna shut off the stream now, but I hope to talk to everybody soon. And yeah, feel free to reach out if you got any questions. And yeah, maybe even make a PR on my repo if you want to add something to it. That would be cool too. Or fork it. Have fun. All right, take care everyone. Bye. Have a good day. Stay safe. Stay healthy.